Hey 7th graders, it's Mrs. Cervantes, and normally I'm with Mrs. Talati, but she's in a meeting today. So I'm going to do this video by myself, a little bit different, not as much fun, but we'll get through it. We're doing 3.1 rational numbers and decimals. Your I can statement for today is I can convert a rational number to a decimal. Some of you may remember how to do this. This will be a review for some of you, and some of you are going to need some more practice at this. So let's write down our key terms. Pause the video and write down your key terms if you need to. Today we have rational number, terminating decimal, and repeating decimal. Okay, so a rational number is a number that can be written as a ratio or fraction. Ratio is a fraction. And then be careful, your denominator cannot be 0. Let me get rid of this for you guys. Your denominator cannot be 0 if you're talking about a rational number. Remember, if you're dividing by 0 and 0 is your denominator, that is undefined. You can never divide by 0. Remember the t-shirt I talked about? It's all fun and games until someone tries to divide by 0, because that is undefined, okay? So a rational number is any number that can be written as a fraction. So here's some examples. If I have the whole number 5, 5 is considered a rational number because it can be written as a fraction, 5/1, okay? Same thing with some decimal numbers. So if I have 0.9, that is a rational number because can that be written as a fraction? Remember your place values. The 9 is in the tenths place, so that is really 9/10. So that is also a rational number. So any numbers that can be written as a fraction are rational numbers. Even negatives. So if I say -3, is that rational? Yes. -3/1, or you can say 3/-1, and that's still a -3. That's rational as well. Okay, so just keep in mind anything that can be written as a fraction, as long as your denominator is not 0. Okay, the next one is terminating decimals. Those are decimals that come to an end. Some examples of that might be 0.5. You guys see 3/4 sometimes, so 0.75, -0.12. That's terminating. It can still be negative. Okay. And then repeating decimals have one or more digits that repeat infinitely, so forever, okay? So you guys know that when you're indicating that something's repeating, if I'm saying that 5 repeats, so 0.5555, here, let's write it this way. If that continues on forever, I can write that as 0.5 repeating with the line over. It can be a pattern, so another repeating decimal might be 1, 2, 3, 1, 2, 3, 1, 2, 3, and so I would rewrite that as 0.123 and put the line over the digits that are repeating, okay? So some decimals, when you do the long division, when you're changing from a fraction to a decimal, some of them will come to an end, which would be terminating, and some of them will repeat, which would be repeating decimals. Okay, let's look at your first example. So what Mrs. Talati and I have noticed is, and maybe this is from the time off and all of the different instruction during COVID, whether you were on hybrid, we did packets the one year in 1920, the end of 2019-20, if you guys remember that. But we're noticing a lot of you need to practice on dividing and multiplying, okay? So this is going to get us some of the practice while we're doing it. So write each rational number as a decimal. So remember, rational numbers can be written as fractions. That's a fraction, 5/16. And to change that to a decimal, if this means, if you're reading this out to you, 5/16, it really means 5 divided by 16. So I don't know how, a lot of teachers have different strategies for teaching it. Some teachers talk about the house tipping to the right. So if that tips to the right, the line goes there, and the 5 goes inside and the 16 is out. One is your divisor and one of yours is the dividend, right? So 16 is your divisor and 5 is your dividend, okay? So now, in terms of doing long division, does 16 fit into 5? It doesn't. So you can use a 0 or you can use an X. I'm going to use a 0. Now, I need to keep going, but in order to add a 0, you always have to add your decimal place. My advice would be to bring up that decimal point right from the start, and then go ahead and add some zeros. Now, I add a couple zeros. You may not use them all. That's totally fine. But at least I have them there, and I can keep going with my problem. Oops, I don't like that. Let me change to blue. Okay, so then the next, let's look at 16 times 0 is 0. subtract, and I have 5. Bring down your next one, 0. So 16 into 50. Now a lot of you, I see you sitting there because you're not really sure, and then you're asking if you can use calculators. Use your pencil and what you know about multiplication. Come off on the side, and some of you might want to start at 2. So 16 times 2, that's 12. 2 times 1 is 2, plus 1 is 3. 32. Oh, maybe we can go one more time. So then try 16 times 3. Don't be lazy. Use your pencil and do your work on the side of the paper. 3 times 6 is 18. Put your 18. Carry your 1. 3 times 1 is 3, plus 1 is 4. So that will fit. So 48 fits. So I'm going to say that 16 fits into 50 3 times. 16 times 3 is 48. I'm going to subtract, and I have 2 left. I'm going to bring down my 0. And then I'm doing 16 into 20. So now, how many times does 16 fit into 20? 1 time. Line your numbers up here over the number that you were putting it in. Okay, keep everything lined up. 16 times 1 is 16. I have 4 left. I bring down my 0. 16 into 40. Oh, you can look over here. You had 32 and 48. Well, 48 is too high, so it must be 16 times 2. Gives me 32. Then I subtract, I get 8. I can add another 0, bring it down. Oh my gosh, how long are we going to have to keep going on this one? So sometimes you're going to keep going. So I've got 80. Oh, how many times does 16 now fit into 80? Well, maybe I'm not sure, but I know that 3 times from over here gets me 48. So I'm going to try 5. So 5 times 6 is 30. Carry your 3. 5 times 1 is 5, plus 3 is 80. Oh, so it fits exactly 5 times. So put in your 5. 16 times 5 is 80. Do your subtraction, and you're at 0. So now you're finally done. So this one would be considered a terminating decimal because there's no pattern there and it ends at the 5. So 5/16 is really 0.3125. Okay? All right. Let's look. So go slow. Keep everything lined up. Let's do B together. All right. And then did you see how much room it took to write that out? So take your time to write out your problems. If you come in with just an answer on your paper, we're not going to give you credit. We know you can plug these into a calculator just fine and get the answers, but we want you working on doing the computation and doing the calculation. Okay? So 13 over 30 means if I tip my house to my right, my 13 goes there and my 33 goes here, and my 13 goes here, and I can draw in my division bar. Okay? So 33 into 13, or the other way to say that is 13 divided by 30. Now, does 33 fit into 1? 33 does not fit into 1. So I'm going to put my 0. 33 times 0 is 0. Subtract, bring down your 3. 33 into 13 doesn't fit either. So then we'll call that 0 again. Subtract. Oh, I need to keep going, but I have to add the decimal. I'm going to bring it straight up and keep everything in line. Now I can add some zeros, and I may use them all or I might not, but because they're zeros, they don't change the value of anything. Okay? And because I had 13, I added that 0 so I could bring it down. So now I need to do 33 into 130, and I am going to have to come off on the side because I don't know my facts for 33. But I know 33 times is 90, and then there's 3, so let's go ahead. Maybe I try a 3 and call that 99. So then look, could you go 33 more and be under 130? No, but again, if you have to try it, go ahead and try it times 4. So that's 12, carry your 1, and 13. That's 132, so that's too high. Okay? So 3 times gives me 33 times 3 is 99. So if I subtract, now some of you are forgetting how to do your borrowing with subtraction as well. Some of you can do that in your head though. Borrow from the 3, that's 2. That makes that 10. So I get 1. Oh, I have to borrow again, that's 12. Oh, so 31. Now I still have that left, so I'm going to bring down another 0. Now I'm going to do 33 into 3, 10. Well, if I triple, so that's 4. Let's try 5 or 6. Let's try 6. See how I'm doing this on the side of the paper? 6 times 3 is 18. 6 times 3 is 18 plus 1, 198. Okay, well, let's try 8. Hopefully you guys can still see this on the screen. 8 times 3 is 24. Put your 4 down, carry your 2. 8 times 3 is 24 plus 2 is 264. Oh, so maybe it's 9. So 33 times 9, let's try that. 27, put your 7 down, carry your 2. 9 times 3 is 27, 28, 29, 297. Oh, that's about as close as I'm going to get, because if I go 10, I'm at, what, 33 into 310, that would be 330. So let's use 9, and that's 297. So then what do I have left here? Borrow, I have 3, borrow, and I have 13. Oh, what's going to happen? Bring down your next 0. So what am I looking at? I'm looking at 33 into 13, or 130 when I bring the 0 down. So I'm right back here, and we can look over here and we see that 33 times 3 got me 99. So what's going to continue to happen? So then I have 31 again, which is what I have left here. So it looks like my 9 and my 3 are going to repeat. So notice how I'm only putting the repeating line over my 9 and my 3. Oh, well, should I put it over the first 3? Yes, look. So go back. I had 13 there. So always check your answer. We could go back. The repeating line goes over the original 3 and 9, because this would continue to be, and let me do this in a different color, this would continue to be 3, 9, 3, 9, 3, 9. So the pattern of 3, 9 repeats. So you do not need these 3 9s. You only need the first 3 and the first 9 with the repeating bar over it to write your answer, okay? All right, so look how much work that is. So you guys need to be patient and don't be in such a rush. There's nowhere that says a math problem. When we do -2 times 3, of course that's fast to do, but when you're talking division and converting rational numbers into decimals, those are going to take you some time, okay? So be patient, take the time to do it correctly. All right, let's look at the next example. It says that Sean rode his bike 6 3/4 miles to the Science Museum. Write 6 3/4 as a decimal. Well, there's a lot of you guys that already understand that 3/4 is 0.75. But I'm going to show you as if we don't know that, okay? So I know 6 is a whole number, so 6 and 3/4. And so if I need to figure out what 3/4 is, isn't that saying 3 divided by 5? So if I tip my house to the right, or sorry, 3 divided by 4. So 3 being divided by 4, and I can do the long division on this. So how many times does 4 fit into 3? It doesn't. So 4 times 0 is 0. Subtract. Oh, I need to add a decimal so that I can add some zeros. And let me get blue again. Nope, that's purple. Okay. All right, so let's look at now bringing down that 0. So 4 into 30 goes 4 times 8 is 32. 4 times 7 is 28. So here comes knowing your facts, right? So 4 times 7 is 28. Subtract, and I have 2. Bring down another 0 because I'm not done. Now 4 into 20. Well, 4 times 5 gives me 20. And that leaves me at 0, so I'm finished. So this is a terminating decimal. So 3/4 is really 0.75. So I know that if I'm talking about 6 3/4, I'm talking about 6 3/4. 3/4 is 0.75. Okay? Some of you knew, and you can relate this 3/4 to money. So how much is 3? If you're cutting it into quarters, think money. 3 out of 4 quarters is 75 cents. Okay? So some of you may not have had to do the 3 divided by 4 right here. But when we get to some numbers, some fractions and rational numbers that are not so easy, this one relates to money, so that's a little bit easier. You will have to do the long division, okay? All right, let's look at the next question, which I think I gave you guys as practice writing mixed numbers as decimals. So let's look at, let me see how many practice problems I gave you. No, I think that one was for practice. So I want you guys to do this on your own as your additional practice. So do this word problem about Yvonne and the watermelons for your additional practice. Okay? Oops. Spelling that wrong. You do that one as your additional practice, and then continue doing and just converting over, doing basic computation. Now, if you look down below of your additional practice, there's an area on your page that says show your work here. You guys need to show the division. So on your separate sheet of paper, number 1, so I'll show you how you should do it in your notebook. Number 1 is 3 divided by 5, or 3/5. We need to see 3 being divided by 5 and show your work. So you have the 0, your decimals, right? So show your work for these, or you will not get credit for your notes, okay? Bring your decimal up and show your work for each problem. In the space below on your note taker, and you can flip up your tab to your note taker and put the rest of the work under there. You can also use a separate sheet, that's completely up to you. But practice with these problems here in the additional practice, and finish this problem about Yvonne, sorry, and the watermelon, okay? If you need help, rewind the video, watch again how to do the long division, because some of you are struggling with that, but we understand there were some things you didn't get a lot of practice on during the whole COVID and quarantine and shutdown, okay? All right, you guys have a great afternoon. We will see you tomorrow. Bring in all the work to show us. Bye.